same room there.
Do we do *6? We up?
*6.
Hi, Hugh, you're there. Hello, everyone, and welcome to today's Safety and Health webcast. NFPA 70E, changes for 2021 and impacts to your business, sponsored by eHazard. This is Barry Botino, and I'm an associate editor with Safety and Health magazine, and I'll be your moderator for today's presentation. First, we'd like to thank all of you for joining us, and on behalf of the National Safety Council, we hope that you, your loved ones, and all the people in your lives are remaining safe and healthy during the COVID-19 pandemic. We'll start the presentation in a couple of minutes, but first there are some housekeeping items that I want to share with you. As a disclaimer, the views of today's speakers and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or the magazine endorses those items. After today's presentation, we'll conduct a question and answer session with our speakers. To ask a question, just click that Q&A button at the bottom of your screen, type in your question, and press the send button. Please feel free to ask your question at any time at all during the presentation. You do not have to wait until the Q&A begins. We'll try to answer as many questions as possible today about this topic, but we might not get to every question. The good news is that any unanswered questions will be forwarded along to today's speakers. And after this event, our sponsor, eHazard, will be sending along a link with the downloadable slides for all of our audience members today. After this presentation, you'll also be asked to complete a brief evaluation survey, but I'll tell you more about that a little later. This webcast will be archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, please go to safetyandhealthmagazine.com/events, or you'll also receive a link in our post-event email. With that, let's introduce our speakers today. With us are Hugh Hoagland and Zahir Juma. Hugh works as the service line manager with Arcware. He's a member of both the ASTM F18 and IEC TC78 technical committees, and he serves as an associate editor for the IEEE Electrical Safety Committee. Zahir is an electrical engineer with eHazard. He's a member of the IEEE 1584 Technical Committee, which will have technical impacts on NFPA 70E for 2021. Again, we thank you all for tuning into this presentation. And Hugh, whenever you're ready, go ahead and unmute yourself and take it away.
I think I'm unmuted now, correct?
You're great. Go right ahead, Hugh. Thank you.
Thank you so much. So I'm going to start off very quickly just to introduce Zahir. He's going to follow up. He's going to do the first part of the presentation. I'll be doing the back part of the presentation. But we're both in the same office, so we're both wearing our masks. And I'm going to slip out of the room just so we don't add any other things to the air. And we will be wearing our masks the entire time. I think you're seeing us on video. If not, we are in the same room, but I'm leaving right now. And Zahir's going to take it over with the changes in NFPA 70E.
Hello, everybody across all the different time zones. Hopefully I'm coming in loud and clear. And yeah, today what we're going to do is Hugh and I put on a little slide based on our interactions with the changes on 70E being present during the committee meetings. And there's a lot of details that go in when a standard change. And what we wanted to do was bring over the important information to you all as safety officers, as safety practitioners, and as folks who are on the tour performing this work every single day. So there were major changes, and we call them significant changes, and there were other changes which were just re-emphasized to elaborate on the meaning of the intent of the standard. So changes occurred on Article 110. We saw changes with regards to arc-resistant equipment, and one of the big additions, in fact, it's got an entire dedicated section to it in the appendices under R, Appendix R, is capacitors. And we'll talk about capacitors in the upcoming slides. And for those of you who have been following this regularly, the standard that we use for calculating our arc flash incident energy, 1584, has gone through some major changes. Now, most of you are aware of these changes, but for those of you who needed some sort of a simplified interpretation of it, what we thought about doing was making it very practical, very simple. So notable changes, obviously, the one that I've mentioned was the one for capacitors, and we'll speak about that. Arc-resistant equipment. Arc-resistant equipment does not mean equipment that is immune to an electrical arc flash. What it means is that if an arc flash has to occur on the internals of that equipment, that energy is constrained and redirected into a safer zone away from the worker. It does not mean that that equipment will not fail and result in an arc. It just affects the influence of the arc to the worker. We'll also talk about the updates to 1584. We'll speak about Article 110, which is the electrical safe work practices, and you will get into a lot of detail with regards to PPE. So on the meaningful changes, one of the first ones was capacitors. Now, for those of you who probably are not familiar with electrical equipment, think of a capacitor as a type of a battery. Think of it as a type of a reservoir that stores energy. Now, it stands to reason that anything that stores energy under failure conditions, it will discharge that energy. And capacitors discharge that energy extremely aggressively. And over the past few years, there's a safety conference that we attend and we generally speak at called the Electrical Safety Workshop, which is hosted by the Institute of Electrical and Electronic Engineers called the IEEE. And over the past few years, there's been lots of discussions with regards to capacitors. So from a practical point of view, where do you see capacitors? For those of you who have a lot of motor loads, where you've got, let's say, things like conveyors, you've got HVAC systems, you've got heating, you've got cooling, you've got airflow, what happens is that that affects your electrical bill at the end of the day. And these capacitors are installed to bring down your what we call the maximum demand charge. And so you get capacitors installed to fix up your electricity consumption so that the utility doesn't overcharge you. The other area that you would find this in is if you have control panels, and in those control panels, you've got variable frequency drives. Those are typically where you would find capacitors. And don't forget, the other areas is research and development laboratories, where capacitors are found abundantly. So the question was, when should we worry about capacitors and when should we not worry about capacitors? So here's the main principles and the ideas that were conveyed within Chapter 3, which is 360. And you can see within the Annex R, they go into all of the details on what happens if you short circuit a capacitor, what happens if a capacitor fails, how do you determine what is the energy that's going to be released when a capacitor is present. So folks, from a practical point of view, if we could simplify this to the nth degree, here's what you need to do. You need to ensure that wherever you have these capacitors, that they are either electrical equipment in place that prevents contact, because like a battery, all the energy doesn't magically discharge as soon as you switch off the equipment. There's a discharge time, and you've got to wait for that discharge time. Now, you've got to be very careful, because we have seen folks who think that, well, if I ground the system, it's going to be safe. Well, think of a capacitor being a battery, and the battery slowly discharging. As soon as you hang a ground on it, boom, you've just created a short circuit. So generally, it takes about a minute or so, 2 minutes, worst case, to discharge some of these capacitors. But in industry, we've always taken the approach, wait at least 5 minutes. Wait at least 5 minutes before you try to make contact or even hang a ground on any capacitive equipment. Now, another change that we've seen is some of you have performed an arc flash engineering study, and some of you have used the NFPA 70E tables. The changes that we've seen on the tables, very, very practical. And what they're doing now is they're speaking about arc-resistant equipment. And why is this change about arc-resistant equipment, and why is it becoming so prevalent now in NFPA 70E, and why are we going into more details? Well, when you looked at arc-resistant equipment, initially when it was first launched, it was predominantly for medium voltage or the higher voltage equipment. But as time progressed, we realized that, hey, we can bring this technology down to lower voltages, 480 volt systems. So now what you see is motor control centers, which previously didn't have any sort of arc resistant protection. Now you get motor control centers which are actually arc resistant. What that means, if an arc flash has to occur within a bucket, it basically will channel that energy out to a safer area and vent it out to an area which is not populated by the worker. Okay, so into a safe area. And what they basically are now saying that even if you do have arc resistant equipment, what we do sometimes on motor control centers is if we have a problem on a motor control center bucket, under certain conditions on some of the newer equipment, you can actually remove that entire bucket and you can replace it with a new bucket. And what 70E is now saying is that although this equipment is considered arc resistant, there is a greater risk of an incident occurring. And that is why they say, irrespective of the equipment condition now, there is a likelihood of occurrence. Then they go on to medium voltage switch gear. And medium voltage switch gear, folks, those would be the ones generally managed by your facilities department. Those are the ones where you would be able to use a tool and rack out, remove or insert a circuit breaker for control of hazardous energy purposes. And what you see here is that if you have arc-rated equipment, and you can see that from the bottom two rows, if you do have arc-resistant equipment, basically what they are saying is for low voltage as well as medium voltage equipment, if you use it according to the manufacturer's guidance, what they are saying in that instance is that the probability of an arc flash is almost negligible. So in that case, what they are saying is that, yes, the tables will allow you to perform that work without necessarily using a Category 4 flash suit. And for those of you, I think Hugh will be covering this a little bit later. A Category 4 means minimum 40 calories per centimeter squared. You cannot use a face shield. You've got to use an arc flash hood on those. So let's talk about 1584 very quickly. And 1584 is basically an area that I've been very involved in. Hugh has been involved with a lot of the, he has been privy to a lot of the testing that has gone on, has spoken to the folks that performed that testing. And if you all have any questions with regards to the details of how some of those values came about, drop us an email later on. Hugh will provide some of our contact details. But for the purposes of today's presentation, here's what you need to take away. When the standard was published back in 2002, the idea was, let's get something that can help folks, okay? And within that time, limited budget, limited understanding, limited equipment availability. And so what they did back in 1584, 2002, was they provided us a guideline via standard, an IEEE standard, which was the best that we had at the time. But over the years, they realized, folks, we need to do a little bit more. We need to test a little bit more. And you can see that the equipment configurations that they looked at previously actually jumped up from 9 on the previous standard up to 45 changes. Now, there are two very important changes that we want to bring to your attention, and we're going to get into the details of it now. The first is that orientation of the electrical bus, the electrical copper or aluminum bus work does make a difference in an arc. And you can see here, this is research done by Marsha Eblin from PG&E. A lot of this work was funded by EPRI and contributed towards some of the EPRI research. And what you can see is on the left-hand side, you've got a very focused arc within a certain equipment configuration. You change the direction or the configuration of those bus bars, and all of a sudden, you can see you've got a much larger fireball. And the reason that we're showing this to you is because you've got to factor this in that you've got to look at the direction of the arc. And as you can see on the picture on the right-hand side, you've got a much larger fireball depending on the equipment configuration. Folks, without getting into too much of the details, those pictures on the right-hand side, those are basically all the different configurations that was created for the 1584 standard. And many, I mean, you can see several thousands of tests were performed, several hundreds of them for each type of configuration. And without getting into the details of each configuration, not only did they run the test, but they basically varied voltages, currents, distances between the copper bus. And what has that resulted in? Well, with the number of studies that we've done using the old 2002 standard as well as the 2018 standard, here's what we've noticed. When you have transformer sizes of transformers of a certain size, and your 208 volt systems, your 240 volt systems, what we've seen is on the studies that we've done previously, we came up with energies which were less than 1.2. If you took the same equipment configuration today and we plugged it into the newer standard that is now more representative of the actual energy that we have inside, you can see that the energies have now been corrected. So previously where we were underestimating the energies, now when we rerun with the same equipment configurations, previously where we said to folks, hey, this is safe, you don't need to use arc-rated clothing. Now we're putting on the folks behind at least a level 2 or a category 2 type of clothing ensemble. So let's talk a little bit more about this. It hasn't only affected us on the transformer sides, because on the previous slide, what we showed here was 2002 said, hey, if the transformer is below a certain kVA rating, you can ignore it. Now they've done away with that. But there's also another requirement with regards to inputting your configuration. So previously, we never inputted our configuration. It was, hey, you're working with medium voltage, you're working with low voltage. Within low voltage, you enter your parameters and boom, you get a number out. Now we need to say, is this a VCB? Is this an HCB? Is this a VCBB? Is it open air? Is it in a box? And when we enter that information now, what we see is the energy actually jumps up from 100, where we calculated previously, up to 140. Now, a lot of you might think, this is not really practical because no one really works at that level of energy. No, folks, there's other instances as well where we've seen here on example number 1, where using the 2002 model, where we came up with 24 calories per centimeter squared, at 2018, we enter it, we come up with kind of in the ballpark 24 calories per centimeter squared. However, if we correct the copper bus configuration, we can see that the real energy is 42 calories per centimeter squared. And so in another example where we had 41 calories from actual testing using the 2018 model, we now see that the real value is 71 calories per centimeter squared. Actually, I used the wrong vocab there. Using the 2002 calculations, on the previous example, we ended up with 40 calories per centimeter squared. Now fixing it, we get 71 calories per centimeter squared, which is much closer to the actual value that you measure using a calorimeter. All right, and when maintenance is performed on equipment, just moving on now, coming back to these tables, basically if you have removed covers to get an infrared image, or maybe you tightened a loose connection, during the first operation of that circuit breaker, now what 70E is saying is that irrespective of the condition of the equipment, there is a likelihood of arc flash, and because of that, you need to be protected. And Hugh, do you want to take the job safety planning? All right, and now I'm going to hand over to Hugh.
Thanks, Zahir. So as he slips out of the room, talk real quickly about job safety planning. So there's now a new tool. It's a job safety planning checklist example. So one of the great things about having something like this is you can develop this, you can customize it for yourself. It's in the annex, so in this case, it's non-mandatory, but it's an opportunity to look at all the different things your electrical people should be thinking about when they're doing a job safety plan. So it's a new tool in the 70E standard, and many companies will want to adapt this for their use in their electrical safety program. So refinements. When we look at the standard, there's lots of things that are just refinements. Some of those will have impact on your program, some will not. Many of them are just organizational refinements, and we didn't go into every place where they moved something. But be very careful when you read these standards new. If you see something struck out, it may be that it's not gone out of the standard. It may just have been moved. There were quite a few things that were in different sections, like 130, that got moved to 110. So when you're looking through the strikeout, don't assume that it disappeared. if it's struck out, it may have actually appeared somewhere else. And so that's one of the oddities of any of the NFPA standards. They'll strike through if something is taken and moved. So just read it very, very carefully. And we'll talk about some of these refinements rather quickly because there's not extreme emphasis. One of the things is it pulled out of 105 an application of safety-related work practices and procedures and moved it. So it's still there. It just put in the idea of priority has been pulled in. Priority hazard elimination shall be first. These are all things that if you're a safety professional, you always want to have the priority hazard elimination. They just want to clarify that that's exactly what they mean. Details creating an electrically safe work condition for the purpose of temporarily eliminating the hazards. They just clarified that electrically safe work condition is a temporary state. Then also, they looked into general and the language subjects, and this was pulled from 120 lockout tagout principles and put into 110, and the electrically safe work condition and the energized work. So what it did was it just kind of logically went through things that were in different places and made them really clear in 110. So I'm not going to go into a lot of detail, but that's exactly what happened, just to make it all in one place and make it more clear. They've also added an informational note to the idea of an electrically safe work condition, that it's not a procedure, it's a state wherein all these things are done. So creating the electrical safe work condition is a procedure, but the state is the state of actually being de-energized, locked, tagged, grounded in a place where it's actually safe for a worker to work on without PPE after that's been created. Another thing that's done was adjusting the numbering and reflecting some assertions in the 110 section to try to put things in logical order. You know, things just gradually get put into the standard, and sometimes they're not in the most logical order. And then equipment use shall be in accordance with the manufacturer's instruction. This is new, but this is something that you would assume from the National Electric Code, but because it is a safety issue, they decided to add that to NFPA 70E, so it's very clear. And then 110.5 is now there's a requirement in your electrical safety program, and you should have a written electrical safety program. It shouldn't say a one-page, we follow 70E, because 70E may not be specific to your exact work situation. So you want to get a template, eHazard has templates, or you want to write your own electrical safety program. But one of the things you want to add to it to be in full compliance with 70E is an electrically safe work condition policy. And the policy gives guidance to managers, upper management, whoever, as to when you do allow someone not to create an electrically safe work program and when they should create the electrically safe work condition, not program. So making sure that people understand when you require full lockout tagout and when you will allow people to use PPE and go ahead and do something without lockout tagout, which should be relatively rare, but work settings, it happens all the time. Another little tweak in 110 is a little instruction on classroom training can include interactive electronic or interactive web-based training components. That may or may not satisfy all of OSHA's requirements, but in 70E, they certainly do allow that. I think blended learning is the future. We're doing a lot of that now that we're in COVID, but I think it always has been something that people wanted to gradually move toward. There's still a lot of opportunity for using classroom training that's live and also some computer-based type training where it's just introductory and then making sure people understand it with some kind of a live instruction. Host and contractor responsibilities, more than one employer shall be responsible for identifying the hazards. So it's just making clear that both the host and the contractor are somewhat responsible in some way for making sure that they identify any of the hazards. PPE issues that are clarified. This section, I think these are all my proposals. Yes, they are. Outer layers, high visibility apparel has been added to outer layers. It must be arc rated, but it doesn't have to be the greater than or equal to the estimated incident energy. So the reason here was a lot of people were going out and buying 8-calorie vests and then wearing an 8-calorie shirt underneath them. If you have an 8-calorie exposure, you can wear a 3-calorie or 4-calorie vest over top of it. It needs to be arc rated, but it doesn't have to meet the hazard because the garment underneath it will meet the hazard as long as it's not a melting vest. So it says it has to be arc rated for high visibility garments. This helps for heat stress and things like that. Instead of buying an 8-cal vest and then putting it over an 8-cal shirt, you can buy a 3, 4, 5-cal vest for high vis, but it's arc rated so it won't melt or fly onto the face and melt onto the face. Then we also had non-leather footwear is really, really common now. There's not an ARC rating requirement for footwear, but the standard used to just say leather footwear or dielectric footwear, which is like a rubber boot. But now what they've said is if you show that the footwear doesn't ignite, melt, and drip in an ARC test at the ARC level that you need it to be protective to, then it's allowed to be non-leather. You don't want to use these tennis shoe type safety shoes that are EH rated. They will melt onto you, but some of the really thick nylon type ones, or some that are partially leather and partially not leather, have been tested now. So get with your manufacturer if you want to use those type shoes. All leather, you eliminate any concern, but if not, you can have some freedom there. Protective clothing PPE, other arc flash PPEs permitted if it meets the requirements of 130.7. Just gives you a little more freedom if you have some oddities that you need that are not arc rated. And then also glove options listed in the category instead of the alternative choice in the footnotes. So there's just a little more clarity, a little more openness in some of the places where we needed that for different work situations. Then they added a maximum use voltage chart. This is already in the ASTM standard that was cited, but they went on and put it right directly in the standard, which is useful. Added PPE equipment standards from IEC. So the nice thing here is if you're a U.S. multinational and you do business in Europe and you have facilities in Europe, you may want to be able to use these IEC standards, which are exactly the same ARC test. There's a slight difference in -2 on the vertical flame test, but these work quite well. And we do this testing at ArcWare. So I'm very comfortable, and I asked them to add these so that the U.S. multinationals didn't force people to buy an ASTM standard garment, which may not even be made in their country. And so they're able to use the IEC standards because they are equivalents. This is just the evolution of the standards and making them more international and expands the applicability outside of the U.S. But from a practical perspective, there's little difference, and this is nice for cross-border companies. Then also it added ARC protective blanket selection, care, and use, which is a new standard we wrote in ASTM. And that is how to use ARC protective blankets. It's a really useful standard. There's still a lot more work that needs to be done and research on this to help people understand all the different places they can use them and how to use them. But this gives you some guidance based on several utilities testing that they've done. The term for barriers has just been refined to make it really clear that it's not the same as barricades. In a couple of places, the language wasn't quite as clear, and it also said shall be guarded by a barrier when an employee is within a restricted approach boundary, or you have to wear all the PPE. So just making it a little more clear. And then the definition here of barrier removed or to prevent unauthorized access, because that's really what a barricade would do. And so that term was actually confusing itself with the other term barricade, and clarified that. Then also in 130, there's some revisions to simplify and improve clarity. I'm not going to go into all the detail here. I want to make sure we have plenty of time for questions, and we're in good shape though. So we'll go to quick detail. Working at or close to the limited approach boundary, they simplified this to eliminate designated person in charge. So typically this is the kind of language that electric utilities use, where they always require 2 people to do work, and that made it seem as if you had to have 2 people to change out a receptacle, and that's not the intention here. So if your program decides you're going to have 2 people, say for over 480 or for over 1,000 volts, you can write that into your program. But this language that kind of assumed that you had to have a separate person in charge was clarified in more than one place, and that was the goal, is so we didn't have something that was confusing. Other precautions for personnel, they deleted some non-essential language throughout 130.8. And then in 130.9, they went into the equipment grounding, replaced near to within the limited approach boundary. In the old days, in the very first versions of NFPA 70E, we define near as being within the limited approach boundary. And this is one of the opportunities that we didn't fix that, because we got rid of that definition and just used limited approach boundary. And the idea of near, that's what OSHA uses the term near. And this is kind of what they mean by near, but we had never eliminated that out of this one section. So that was done, so it made it clear. Global changes to improve consistency and eliminate redundancy. Verified is changed to test for the absence of voltage throughout the standard, so it's clear what verify means. And then normal operations been deleted as part of the likelihood of occurrence table. And this footnote points to 110.4D. Cord and plug, cord was changed to plug connected, so it's very clear. And then equipment with doors closed and secured was put in because in some cases, the equipment is perfectly safe. Arc-resistant equipment, for example, is perfectly safe with no PPE as long as the doors are closed and secured. But if they're not closed and secured, then arc-resistant equipment, in many cases, unless it's arc quenching, is actually the same as regular switchgear because it can still blow up inside. It just normally shunts the energy away, but it has to be closed and properly secured. We've actually seen an incident where someone closed the door back on arc-resistant equipment, but they didn't want to put all those bolts in because that was a lot of trouble. Had a lot of bolts in it. Those bolts are there for a reason. So you do have to secure them, and you should torque them correctly according to the manufacturer's recommendations. When you remove any arc-resistant equipment doors, needs to be put back exactly as the manufacturer made them because they're there to shunt the energy or contain the energy to make them safe. Some other definition revisions, and I'm not going to go into a ton of detail here, but all of these revisions were tweaked a little bit to make sure that they were more clear. The balaclava, there's variable design, so they removed the term sock hood and defined what the facial area that a balaclava covers. And then all these other terms have been clarified just a little bit, and we didn't really have any big problems with those. We want to make sure people understood what they were. And so just at eHazard, we like to use our E's, and we want you to have basically a dimming model for everything in your program. You want your electrical safety program to envision, execute, evaluate, and then when you need to change it, you evolve it. Same thing with your risk assessment, your ARC class studies. Periodically, go back and look. Like right now, those 1584 changes will change some of your equipment. So go back either to your previous company that did that, or go to eHazard, or get to with your engineers and go back and look at 1584, recalculate with this new version, because there will be some places that it will affect your PPE levels. Training, making sure that that's looked at periodically, updated for the new version of the standard, like we do with our training. And then investigations, making sure that you're looking at how does that investigation, that particular incident, how does that affect my electrical safety program? How does that affect my risk assessment? How does that affect my training, to make sure that we're using those investigations to actually learn something rather than using them to blame? They're never useful if you don't make a change to the process. If you just blame a person, you've not learned anything. And almost every incident investigation I've done, I've learned something about the PPE, about the program, about the training, about the culture for the safety. So making sure that you're going back and using those incident investigations, you're using your audits, and you're doing the maintenance so that you have fewer and fewer incidents and you have a more reliable electrical system. So these are requirements in 70E, and hopefully we'll get to good things. So I'm going to skip past that, and I guess I've got a couple of slides here I've accidentally recreated. I'll ditch those. Sorry about that. And here we go. So I repeated some slides. I apologize. Cintas is our sponsor today. They wanted you to know that they provide PPE. They rent, lease, sell PPE, and they will clean and replace and repair any PPE that you want them to. They're a good supplier here in the United States, especially if you need a laundry service. They're fantastic at that. And the other thing is that I didn't know this until just a few months ago, that they actually have a managed program for rubber insulating gloves. Each worker gets 2 sets of rubber gloves, one color than the other color. So every 6 months they switch out, and they make sure that your rubber gloves and your leather protectors are provided for the workers. And if you need clean ones, you put them in a bin and they replace them. And I was quite excited about that. We have more than one company that's looked at doing that. It's something you don't have to manage in-house anymore, because it is required by law and by 70E that those gloves be tested every 6 months. So there's opportunity there. If you want to reach out to Cintas, you'll definitely have that opportunity. And now we're going to open the floor for questions.
Well, thank you very much, Hugh. Appreciate that. And thank you to you and Zahir for sharing your expertise with us today. Just a reminder to our audience members, if you would like to ask a question, click that Q&A button at the bottom of your screen. Go ahead and type in your question and hit that send button. Before the Q&A starts, I want everyone to know about an evaluation survey that we're asking you to complete. The survey will open up in a different window on your screen after this webinar, and your input is really important to us. It will help us to improve our future webcasts. So now let's go ahead and get to some questions, Hugh. A couple of folks are asking about a timetable about when the standard will be released and also when changes will take effect. Can you tell us a little bit about that?
That is actually a fantastic question, and I should have even covered it. It actually came out September 15th. It was in effect 15 days after the publication. But just recently, it's been 70E made a major change, and I really should put a slide on this too. Previously, you could buy the 70E standard in a PDF, so you could cut and paste, work with it in your program, answering questions, things like that. That has been eliminated from all NFPA standards going forward. And so now they have something called the NFPA Link, LNK system, and you can share that with a team of, I think, up to 10 people. You can even share it with larger teams if you pay more. But it's actually a really cost-effective way to use the standard, but it's already in effect. You can either buy the physical copy and put it in front of your workers or put it in front of you for building your program, or you can sign up for the Link program. I encourage anybody who's going to use the standard a lot to look into the Link. If you're going to do training, it's nice to put a 70E in front of people to be able to use in the class. But as far as day-to-day use for the program, you want to sign up for that Link program. It's got lots of things in there. You can use the National Electric Code in it, and it's a new service from NFPA. It's currently not available offline, but with our smartphones and tablets now, you pretty much have internet everywhere. But if you don't in your location, just realize it's not available offline. And hopefully they'll get that rectified, because we have given them a lot of feedback, because there's some places you don't have internet. Okay?
Sounds good. Thank you, Hugh. We did have a question come in regarding arc flash clothing, and someone mentions that the question, can arc flash ratings be added for multiple pieces of PPE? For example, does an 8-calorie vest and an 8-calorie shirt add up to 16 calories?
Well, and that's not possible. It has to be tested as a system, but in the case of a vest and a shirt, because you don't cover the arms, unless you're using rubber insulating sleeves or something that's covering the arms, you couldn't take advantage of a vest as adding to your arc protection. But we have seen in some cases, say an 8 over a 4 doesn't equal 12, it actually just equals 8. So the 70E standard and the 1506 standard warns you to make sure you actually test the system. And if you test the system and say you put a coverall over top of your shirt and your pant, then you absolutely can use that to get to, say, 20, 25 calories. If you go to arcwear.com, we do not sell clothing, but if you go to arcwear.com, click on resources and come down to 2-layered systems, we have a lot of brands that have been tested that are free data, and you can find that data there. And if you can find those 2 specific types of fabric, buy coveralls with the one, buy shirt or pant with the other fabric, and you'll have the arc rating already. When you're buying from the same exact company, if you're buying, say, a Westex fabric from a Westex or a Glenguard fabric from Glenguard, and you get 2 layers, they'll provide that data. But when you're mixing brands, you can use that as a resource.
All right. Thank you very much, Hugh. We had a question come in about capacitors. The person mentions that this was an excellent discussion about capacitors. But the question, Hugh, is in lockout tagout, we always train that you must dissipate energy from a capacitor. How do you go about dissipating the energy from a capacitor?
And there is guidance in that, and I am not an electrical person. I'm an arc flash person, flame and thermal person. But dissipating energy from a capacitor, it's important to follow the recommendations in that annex. Okay. There's also a great resource if you're out there and you're wanting more detailed information on capacitor, because there are some huge capacitors in the workplace that you need specialty guidance to be able to dissipate the energy from. When Zahir was talking, he was talking more about smaller capacitors. Some of those larger capacitors, you want to use the manufacturer's recommendations for energy dissipation. And so that's really important. But there's a great organization called EFCOG, EFCOG.org. And EFCOG is a group of Department of Energy contractors and Department of Energy employees that develop procedures. And actually, this capacitor annex came from EFCOG research at the Department of Energy facilities around the United States. So look on there too. They may have more guidance on capacitors and specific capacitors, but you should talk to your manufacturer if you don't have good guidance in your written program.
Okay, thank you, Hugh. We have gotten a couple questions about downloadable versions of the slides. Just so folks know, at the beginning of the webinar, we did mention that Hugh and his team will be sending out a link with a downloadable PDF of the presentation today, so you will get that after the event today. Moving on to our next question. There was a question regarding any updates. This person said they thought they saw a update in the standard regarding arc flash face shields going from yellow to smoke gray. Is there any truth to that?
Nothing said in the standard.
Okay.
Many of these shields have gone to a smoke gray by not blocking as much visible light, not specific wavelengths of visible light. They're blocking a percentage of visible light with either nanotechnologies or some other types of dyes. And so they are going more smoke gray, and there's an advantage to that. As long as you get enough visible light to be able to see or create by adding extra light in your work situation, that does help you see the colors of wires better. So I would say if you have one of the old yellowish or orangish type shields, you ought to look at the new technologies, because almost everybody in the new shields have gone with the new gray type shields.
All right, thank you very much, Hugh. And we have next question here, someone asking about, will NFPA be providing PDF versions of the standard, or do they do that when new changes come out?
Yeah, that's the thing that happened. Of course, these standards have to be purchased, and NFPA has gotten rid of PDFs, but the link just started this last week. So if you go to NFPA, type in, I think it's LNK, but type in link. And I apologize, we've signed up for it. I'm logged into it, but I forgot to look at the login. But or you can send an email to questions@e-hazard.com, and I'll send you the link. One of the two.
Okay.
But it is available from NFPA for a monthly fee, and you get access to the standard.
Okay, thanks, Hugh. And as Hugh mentioned, his email is right there, questions@e-hazard.com. Next question, Hugh, is what type of testing is done on voltage gloves as far as melting rubber?
Well, if they have an arc rating, we have a standard for arc rating rubber insulating gloves, but there's no requirements in the standard to do that. So as we've had a proliferation of brands of gloves, I do think there's concern on some people's parts. As long as you're not over about 15, 20 calories exposure, the gloves that I've tested are usually not a hazard unless they're very, very thin gloves. But you want to talk with your glove manufacturer and see if they have an arc rating, because they will have an arc rating and they will have a ignition withstand. That's new in the standard, but very few people are labeling their gloves this way because it's not required by ASTM D120. D120 is driven by a lot of utility folks, and some of the utility folks say, we know our gloves, we don't want any extra testing required, and they have a lot of knowledge of their gloves, but for the average person, we don't have a lot of that knowledge. So it is available from many of the manufacturers. I would say check with your manufacturer, but black gloves are usually the hardest to ignite of any of the glove types that are sold. So just ask the manufacturer, and they probably have the data. They may or may not share it with you, and you have to get through to their technical person. You're not going to get it from customer service or from most distributors, but you need to get it through to their technical person, and that you have to ask them about that. I can't release the data because we're a ISO accredited lab. Okay,
sounds great, Hugh. Next question, we have another couple questions about gloves, and specifically about if electrical gloves are not tested, should they simply be replaced every 6 months?
You certainly can replace them every 6 months, but there's a real backlog on rubber insulating gloves. So please, please, please test them. So it's about $5 to $15 to get gloves tested. The gloves cost somewhere between $60 and $120. So it is worth taking a little time to test them. But a lot of companies do. But they have to be tested when you receive them within 6 months. So if you buy them directly from the manufacturers, some of those manufacturers, they may be sitting on the shelf for a year before you get them, or 6 months, depending on the size. So it is very important that you have a good testing program. Obviously, that Cintas program takes care of that for you, or there are many distributors that will take care of that for you. And it's fairly inexpensive to get gloves tested, but you do have to ship them somewhere and they get shipped back. And usually it's a 2-week turnaround. But if you go to NAIL, N-A-I-L, the number 4, P-E-T, NAIL, the number 4, PET.org, that's all of the accredited NAIL glove testing organizations. And so you can find those folks that are accredited for that. And it is a not-for-profit and excellent organization to keep up with those who are accredited glove testers.
Okay, great. Thank you very much for sharing that resource, Hugh. Next question, someone asks, if I had an arc flash analysis done prior to 2018, is it outdated? And do I need to have another one done so the calorie ratings are correct?
That's a good question. It's going to affect just those 2 types of equipment mainly that Zahir mentioned. If you have less than 75 kVA transformers, you want to look at those. Less than 125, I think, was the original number, right? Yeah, you want to look at those. And then in 150s, you want to look at particularly. And if you have any switch gear that have ejected electrodes, then you want to look at those. So switch gear and say 208 systems would be the main types of system. 3-phase 208 systems and switch gear would be the 2 parts of your program you'd want to kind of look at. Usually you can go back to your engineering firm or you can come to a company like eHazard. They can look at the program, look at the equipment, and see if there's equipment that needs to be redone. If you have those original files, which we always give out with our studies, any engineer can take those, import it into their software, and just look at what effect there is on specific pieces of equipment. You don't have to redo the whole study, and there's no requirements to do anything except every 5 years. But when the standard changes and there's now new requirements to be in full compliance, you want to look at anything changes that might affect you. If you're using the tables, very little has changed, but many people are doing arc flash studies. So it's just good to review that study. It needs to be done every 5 years anyway, if you're following the standard. So in that review, just make sure they're looking at, because every engineer has different levels of knowledge of this, make sure they're looking at the 2018 version, and they're looking at equipment configuration, which they may not have gathered that information when they did your study. But it's good if you make sure they understand this, that there are changes and why, and they'll look at that specific equipment rather than having to do the whole study over.
Great. That leads into our next question, Hugh, regarding one of our audience members would like to know, how is an arc flash study conducted? And has there been studies conducted on elevator controllers?
Yeah, we've actually done several on elevator controllers, and in a few instances in the feed to the elevator, there is substantial amount of energy. Just depends on the elevator type, but yeah, you can certainly do that, and it's not a horribly expensive thing to do. If you gather the right information yourself, a study can be fairly inexpensive, especially if you're looking at elevator controllers and they're all the same. Once you've done one, it really depends on the utilities feed. You may have very similar energies in lots of different elevators. So it's really important to do that. And a lot of the larger elevator companies have done studies and just made generic understanding. So you might talk with your elevator manufacturer first and see if they have a recommendation on what kind of energy is available on their equipment, or you can have an engineer do that study. And like I said, we've done several of these, and that's a fairly uncomplicated study if you can gather all the correct information. It may just be a few hours of engineering time for the elevator specifically.
Okay, great. And we did have a quick question that came in, Hugh. Someone would like to ask you if you could repeat the website where you can find more information about capacitors.
EFCOG.org. So FCOG, EF, F as in Frank, COG.org.
Okay, great. Thank you very much.
And there's a ton of information on that website, so you have to dig down for capacitors, but there's a lot of information there.
Great, great. And obviously a lot of questions still about gloves. One person asked the question, are all facilities required to comply with NFPA 70E? And is there a grandfather clause for older facilities, or has that elapsed?
There's never really been a grandfather clause with 70E. 70E's been out since 1979. it's a work practice standard. So it's not law. It is a best practice. OSHA uses it for abatement. If you're not following, if you have any kind of incident, they would say, why didn't you use 70E? It's really a hazard identification and safety program, or at least a safety program guidance for building your electrical safety program. So there are no grandfather clauses. It's not like the National Electric Code, where if you built it right the first time, you don't, unless you change the facility, you don't have to go back and redo it. So like NFPA 70, the National Electric Code does have a grandfather clause. There's no grandfather clause in the maintenance standards or in NFPA 70E. So 70B, 70E, they don't have grandfather clauses. But the only organizations that don't have to follow it would be electric utilities. If you look in the very front of 70E, there are some exemptions. Electric utilities in their transmission, generation, distribution system, in their office buildings, in their warehouses, things like that, they still have to follow 70E. It's included in that scope. I think marine organizations are, if you're a ship, I don't think they're under 70E, and there's a few others. I think railroads are under the National Electric Safety Code. However, if you go back and look at the National Electric Safety Code, which is ANSI C2, all of the things in 70 we've talked about in Arc Flash are now covered in the National Electric Safety Code. So there are very few organizations, and the only thing I can think of is probably the Army and the federal government. And I can tell you the Army, my son was in basic training at Fort Benning. He was a company commander there. They even follow 70E type principles, and I've worked with the DOD's electrical safety program, and they're trying to implement 70E throughout all of the armed forces, even though they're not covered by law. They're just doing it because it is the best practice. So very few organizations would not be covered by either National Electric Safety Code, which has arc flash requirements, or NFPA 70E.
Okay, good to know. One of our attendees asks, have there been any changes to the standard regarding fall protection?
No, just that, if it's exposed to arc flash, it needs to meet ASTM F887. The 887 is not mandatory, but OSHA by law has required a 40 cal arc test, which literally is what we do in 887. So anyone in 1910-269 or covered by 1910-269 would have to use an 887 harness, which has an arc flash test, 40 calories, and then it's dropped afterwards to make sure it still works. Most of those will be flame resistant or really, really thick nylon, but they have to have really specific keepers to make sure the keeper doesn't ignite and catch the nylon on fire. So most people are going toward a Nomex or a Kevlar type vest or some of the really heavy nylons that are specially made for arc flash.
Okay. Next question here we have is there a third party or a peer group that I can use to evaluate my electrical safety program and provide some feedback?
Well, that's one of the services that eHazard does, but I'm sure there are other suppliers out there. We have a class on how to write an electrical safety program, and then we also have templates that people can use for the beginning, but we do reviews regularly. And like I said, there's all kinds of organizations out there that do it. Getting one that has strong expertise in the area, they'll catch things. I always recommend that about every 3 to 5 years, have somebody look over your program and make sure that there's nothing that you're missing that may be best practice now that you don't know about. 3 to 5 years should be good enough, and having a third party, and then maybe the next time you use a different third party, because everybody has different expertises, and they may catch things that somebody else doesn't catch. But safety program audit and a site audit go hand in hand. Because, sending, say, us a written electrical safety program, we may not know that you have huge amounts of capacitors that you don't have written into your program. So having a site audit periodically, and I don't mean every year, but again, DuPont, I think, is one of the best practice companies I've ever worked with. They have an outside company come in about every 3 years. And then 1 year you have the safety person at that site does the audit. The next year they cross-pollinate between plants. You go to someone else's plant, they come to your plant, and that way you're cross-pollinating all the time and just improving and improving and improving your program. And so having an outsider from time to time look it over is a good idea. Having a different outsider look it over is a great idea, even though that probably could cut back on eHazard's business. But we want your program to increase and improve. And so cross-pollination within the company, sections, different groups looking at things, and then also going out and getting an outside company once in a while really can help improve your safety program.
Okay, great. Thank you, Hugh. Next question we have is, are arc flash warning labels required on all electrical panels, and are older buildings required to update that labeling where they do not exist?
Well, since 2005, it's been required in the National Electric Code. So that's law in most states. The grandfathering idea, if you've never changed anything, could perhaps apply. I'm not a legal expert. I would always recommend you start the process. The general warning labels of arc flash and shock hazard are not really very useful, but it's better than nothing. I encourage you to use the NFPA 70E standard. If you can use the tables, label with the tables. Many small companies like a warehouse, we have a laboratory here in Kentucky. We've got a 5,000 square foot building. We've done an arc flash study on our electrical panels. And they are slightly more because they're three-phase panels than what the 70E standard would say. So we have made sure that we have our things labeled. But if we had just followed the 70E standard, more than likely we would have done fairly well. But our transformers were a little bigger than normal. So it's always a good idea to have some kind of label so at least there's some kind of warning, because even if people don't know what an electrical panel is, if it says warning, shock and arc flash hazard, basically this can kill you, that kind of helps keep people from opening that door. We had a guy who was putting his lunch inside of a switchgear in a nuclear power plant. He was a contractor and a construction person, didn't know anything about switchgear, but he was putting a metal lunch bucket, literally caught in an audit, putting a metal lunch bucket inside of a 13,800 volt switchgear. If he'd moved that bucket 2 inches back, it'd have blown that switchgear all to heck right in front of his face. And so our inspector stopped him, and from then on, that company locks the doors on there, and only the electricians and the supervisors have access to those rooms.
Thank you, Hugh. Next question we have for you is, has anything changed with in terms of open air battery racks as compared to battery cabinets where an arc flash comes directly out at a person?
Yeah, I don't think there's any big changes there, because I think when we went back and looked at the DC section, and I was on the DC task force, I think we found we were probably on average slightly over predicting. Did we make any changes to batteries, open rack versus closed rack? I don't think we did. So, and again, you have to do a proper risk assessment based on your equipment design. Open rack versus closed rack would be more likely to have an arc flash, but the energy might be the same. So once you remove the cover on the closed rack, then the hazard may be the same, but the probability, the likelihood is different. And so depending on what you're doing, you may or may not require PPE for that particular work setting. But this is all part of your risk assessment and your written program.
Okay. Quick question here we got from our audience. Does arc-rated PPE have to have an FR rating?
Well, arc-rated materials are automatically flame resistant. They don't have to meet NFPA 2112, which is a flash fire rating, but they have to be flame resistant. But by definition, if you meet ASTM F1506, or if you meet the IEC 61482-2 standard and you have an arc rating on it, then it is flame resistant. That's part of those specifications. And so you may see that somebody just puts an arc rating on it, but if it has an arc rating and it meets 1506 or 61482-2, then it is flame resistant. And by definition, at least we should have a vertical flame test to do the arc test, because if it doesn't pass the vertical flame test, it typically will burn off the panel in an arc test. So it's much hotter than the vertical flame test.
Okay. And Hugh, you touched on this previously, but we have someone who'd like to know where they can purchase the NFPA 70E standard from, or is it available free on a website? I believe you mentioned it is available for purchase online.
It is available for free to read. If you go to nfpa.org and you log in, you have to create a username and password, and you can actually read it because it is a code. You can read it for free, but you can't search it. You can't cut and paste from it, but it is certainly available for free to read. And then if you want to purchase it, you can purchase a physical written copy, or you can purchase the Link program, which is a monthly fee, and you'll be able to read it, search it, mark it. It's your copy, so to speak, but it is not downloadable at this point. So NFPA.org. If you want physical printed copies, we do sell them at ehazard.com, e-hazard.com, but you can also buy them from NFPA.org. They're the same price either place.
Okay, sounds good. And last question we have time for one more today. And Hugh, one of our attendees likes to know, do we need to redo our arc flash study, even though we already implemented an arc flash mitigation process?
Well, it depends. It depends on what you've done in your mitigation process. Obviously, if you used a VCB calculation and you have not changed the breaker settings to lower the energy, if you've gone from a VCB to an HCB, it could be double the energy of what you calculated before, and the double energy would be correct, because we did not have those 45 equipment configurations and all the changes in fault current in the 2002 version of IEEE 1584. But in the 2018 version, there will be some places that no matter how much you've mitigated, that you may be off, because the equipment configuration now makes a difference. But if you've got arc quenching gear, man, you've gone so far, or arc resistant gear, you've gone so far. And then also going in and tweaking those breaker settings so you have lower energy. It will be lower, but if the equipment configuration has changed, it might be higher than what you've calculated. And so it is important that you go back as you do your program. And I mean, the difference between wearing a 20 in front of a 40 is probably not going to be someone dying, but it might be them getting more burns than you would anticipate. And so it's really important to go back and redo that study either in your 5-year cycle or as you have funding for it. But I recommend stick with your 5-year cycle. Unless you do have funding, then go out and look at those HCBs, which would be your switch gear. Some of those will be HCBs, and those energies will double. And then go out and look at your 208 systems if they were not studied before, because lots of the companies come in and they give you a set price, but they're not looking at anything below 480. And sometimes they're not looking at anything but your switch gear. So it just depends on the sophistication of this company that's doing your study. They may have actually missed some really bad places. So I always recommend, if you've had your study done, have a different company look at it the second time. Even if it was us that did it the first time, have a different company look at it the second time. And if they come back with pretty much the same thing, but we find some companies have different levels of sophistication, so they're not catching the right things. But that 2018 change for 208 3-phase systems and for switchgear can be really substantial on the PPE changes.
Okay, great. Thanks, Hugh. Well, unfortunately, we've run out of time today. I'm sorry we didn't get to everyone's questions, but a reminder that all unanswered questions will be forwarded along to our speakers today. Again, we also hope you take the time to share your feedback through our survey that you'll find after the event. I'd like to thank our outstanding presenters today, Hugh Hoagland and Zahir Juma, everyone from our sponsor at eHazard, and of course, all of you who joined us today. This ends today's Safety and Health Magazine webcast. Take care, everyone, and have a safe day.